好了，我们来看一下上礼拜上到哪啊？上礼拜上到哪里去了？来，我今天先去复习一个东西，叫做这个好了。来，13之7哦，studied orbit and energy。我想问你，你记不记得 Kepler's law 是什么东西？克普勒有3个定律，对不对？The Kepler's three law。那哪3个定律呢？第一个就是 elliptical orbit，对不对？啊，所以 the law of orbits，他有说过，所有的轨道都不是正圆，它是椭圆。我看，a plane moving in a elliptical orbit and with the sun at one focus，因为椭圆其实就有2个圆嘛，对吧？那再来是 the law of area，which is mean if you just pass through by the same time, you will get the equal area。那第3个定律就是 the square of the period of any planet will be proportional to the cube of the semi-major of orbit。记住什么叫做 semi-major，你知道吗？semi-major 对我来讲啊，它讲的是平均轨道半径。为什么？因为你有一个什么比较靠近那个什么恒星的地方嘛，所以它讲的是 average，就是你的什么这个 semi-major issues 其实就等于什么 r maxima o the average of the maxima and the minima we call the major issues is a。那它会 only related to the mass of the sun and the odds will be constant. It's okay because your gravity is represent the central force for the orbit。那所以你现在看一下左下角的图哦，来，你看一下这个表哦，你看到什么东西了没有？来，左下角表你看一下。你会发现它们的 t 平方除以 a 三方基本上都是一个 constant。So equation 1334 also holds for elliptical orbit, but your central sun should be the same。所以就讲嘛，that's the essentially the same value for every planetary orbit around a given massive body. So it's relative to your massive body, for example, like the sun. So table 33 shows how well it holds for the orbits of the planets of the solar system. Okay, certainly one in a certain orbit around the planet. 2 in a larger circle orbit, which certainly has the longer period and the greatest speed. 好 think about that. For the speed, I think you should try another things. For the g n and r square should be the n r v square, right? That's your centripetal acceleration. So you can get a would be gn over r. So please find this one. since this will be constant, so longer the orbit, longer the period, right? So 2 is greater than 1, and the greatest to be Gn just constant is proportional to the square root of orbit. So longer it will be slower, so 1 greater than 2. That's the answer. Please take a check. If you are okay, please see this one. Comet Halley orbit the Sun with the period of 76 years, and in 1986 had the distance of the closest approach to the Sun. It's the perihelion distance. So the distance is between the orbit of Mercury and Venus. A. What's the comet's farthest distance from the Sun? We call the aphelion distance. So you have the perihelion and the aphelion. Okay. So how could you do the number one? I give you some time to think. Okay. So we will compare with the Earth because the year just the unit for the Earth to count the time. But do you know what's the AU? So I need the data for the AU. Oh, okay, for the Earth. The Earth's 1.5 times the 10 of 9 meter is equal to astronomical unit. It's the definition, okay? So 1 LU cube over 1 year square is equal and how many A cube? And 76 years square. Okay, find the A first. And don't forget the unit is astronaut unit. So the A is about 17.94 astronaut unit. So it's approximately by 1.5 multiplied by the power of 9 of 10. It's approximately 2.69 by the power of 10. That's the measures. And don't forget your perihelion and your aphelion will be twice of the majurations. And it's want to find the RA, right? RA. Supply 2 and the substrate 9.8. So it's approximately, hold on. What's wrong with me? 17.94 by the 1.5 exponential 9, 2.69, yes, approximately. And this will be twice, right? Oh, you get it wrong. So the power of 11. So it's about 17.94 by the power of by 1.5 times the power of 11 of 10. So it will be the 12. So it will be 12, right? 12. Then the subtrate your perihelion. So we can get RA now, right? Your RA is 5.29 by the power of 12 meter. That's my answer. So approximately is true. And what's the eccentricity? Eccentricity. So it will be the aphelion distance subtrate the majurations, right? Okay. So let's get a C first, and your eccentricity is C over A. Or you can write as this one, the E times the A would be the A subtrate RP. Or you can use this to get the, okay, I will rewrite. So the EA would be the RA subtrate A. You want to get the E, right? So it will be the RA to A subtrate 1. And what's the power A? 17.94 AU, right? 1.967 subtract 1, 0.967. Approximately? Are you okay? And the next one would be the Aubrey and energy. Let's read the list first. Aubrey is with its speed, so it's of the kinetic energy, which fixes kinetic energy. And the distance from the center of the Earth, which fixes the gravitational potential energy, C. Okay? So your total energy, we call the mechanical energy, will be the K at U. And we know the M RV squared would be the central force, right? It's similar can rewrite as the 2K, K for kinetic energy over R. It would be the R squared and GMM over R squared. So you can easily get a K would be the GMM over 2R, please. Are you okay? And it will be the half, negative half the potential energy, right? So you add the negative half potential energy would be the half potential energy, that's your total energy. Okay. This tells us that for a satellite in a circular orbit, the total energy E is negative of the kinetic energy. But for the elliptical, you just replace the A. The R replaced to A. A is the majorations. Statement majorations, sorry. Statement majorations, A. You feel okay? Kinetic energy is always positive. And since we total energy is equal to kinetic at the potential, so E will be larger than the potential energy. Please see checkpoint 5, please. Okay. A. Which of the dashed elliptical orbits shown in the figure will be shorter than take? Is the orbit period of the shorter the time returned to P greater than is than or less than in the circular orbit? We know larger the orbit, longer the period, right? So at the point P, origin where you are, at the point P, the pilot briefly fires the forward point thruster to decrease the shuttle's kinetic energy. Briefly fires, okay. Also, at P, it asks you where, which orbit you will go. Okay. Larger the radius, less the kinetic energy. So it must go to the outer one, right? So I choose the OB2. And it will be the greater, right? Since the radius is larger, right? And next one. Okay, please do this one. Sample problem 13.05. A platform astronaut released the bowling ball of mass 7.2 kilogram into a circular orbit around Earth at an altitude of 350. What's the mechanical energy of the bird in its orbit? How do you do that? Think about that. 'You didn't know how to get the GM? I prefer the 9.8 half. It will be the GN and the R squared. And what's the R is? As a distribution of the R is approximately 6,400 kilometer. So we can get easily your GN will be 9.8 multiplied, okay. 60.4 by the power of 6 meter and square. And don't forget your 7.2 GN plug in. 4.014 by the power of this one. Three, 6, 8. Sure, that's my answer. Let me check the answers. 140 millijoule. Yes, that's the answer. Okay, that's A. And the number B. What's the mechanical energy E0 of the ball on the launched at the Kennedy Space Center? What's the change in the ball's mechanical energy? Where is the Kennedy Space Center? Where's the Kennedy? Oh, so it's launched. It's launched the word on what? On the surface of the Earth, right? So need to find the change in both mechanical energy. That's your turn. Your Kennedy, the Space Center is on the Earth. Okay, so please find the total energy. But this time you just have, because launched the no kinetic. So your on Earth. It's only the potential energy. Don't forget the 2. Okay. And what's your GN again? It should be negative GN. 4.014 by the power of negative 14. And sorry, positive 14 by the 7.2. 2 by 6.40. 6,400. 6. Okay, from the list 1, please. Sixty to 6.6, 2.26 by the power of 8 joule. And we do the 1.4 by the power of 8 joule, right? Negative and negative, you just need to subtract, right? The change would be 1.2 by the power of 7. Sure. That's my answer. Wait. 400? Why 400? Who is that? It's Earth, right? Hmm? Oh, I know what happened. I can have the 2 divided by 2. No 2 here. So it will be twice, right? 4.52. Negative. So it will be negative 4.52. So the change will be the delta E, right? Would be 2.38 by the power of 8 joule. That's the answer. Okay? The answer. Because when you just launch it on the surface, you only have the potential energy. And please do number 13.6, please. It's your turns. ？Hello Hello，
喂，
喂，
老师好，请问有听得到吗？
哦，对，我现在已经讲到这一题中，好啊，前面已经有录过了，我先把录的
好的，
关起来。
好的。